So you can use this video here to help you with section 7.7. So our objectives here are to simplify numbers of the form square root of negative b, recognize subsets of complex numbers, add and subtract complex numbers, and multiply complex numbers and divide complex numbers. So before we've talked and said that we typically can't take the even root of a negative number, that is having a negative radicand. Here we're going to get into ways in which taking the square root of a negative radicand can be represented mathematically. Now, for simplicity and to keep these videos somewhat short, this particular video is only going to discuss Objective 1 right now. So the first thing we're going to talk about is the imaginary unit I. I, represented by a lowercase italic I, is the square root of negative 1. So logic implies that I squared is equal to negative 1. So we can say that the lowercase I symbol is the principal square root of negative 1. Now these two rules are going to be very important to remember. So when we're just simply taking the square root of a negative number, as we see here, taking the square root of negative b, it can be represented by putting this lowercase I outside of the radical times the square root of b. So here are examples of what I was getting to in the previous slide. So here we have a situation in A where we're taking the square root of negative 25. So first, the thing that you do is convert it to the format that includes the lowercase I. So notice, because we basically took out that square root of negative 1 there. Now we just take the square root of 25, and the answer is 5i. Now we have a situation in B where we have a negative outside the radicand, but we'll be able to handle that in a similar way. Notice first we're taking out the I and representing on the outside of the radicand, and now we take the square root of 81, which is 9, so that is represented as 9i. Now in C we have a situation where we don't have a perfect square root. So we said the first thing to do is indicate with the lowercase I there, getting rid of that square root of negative 1 part of this, and then that is the simplified as far as it will go there. I square root of 7, because we can't simplify the square root of 7 any further. Now D involves a couple steps, because we can simplify that radicand in a certain way. Remember finding that perfect square factor and those things. So first off, we handle the square root of negative 1 aspect represented by I. Next we look for that perfect square factor, and 44 has a couple of factors there, 4 times 11. So now we're going to take the square root of 4 here, and then now this number can be represented as 2i times the square root of 11. So going to the homework real briefly here. So notice we have here we want to write the number as a product of a real number and I. So what we have here is the square root of negative 36. Alright, so we can think of this in another way. This is the same thing as the square root of negative 1 times the square root of 36. And remember that rule we said is that I is equal to the square root of negative 1. So what we're doing is replacing this here with I. So here we're replacing that square root of negative 1 with I. Now we can simplify this right here into the square root of 36, which is 6. So our answer now becomes 6i. So here again in the homework we have a similar situation as last time. Write the number as a product of the real number and I. The only difference here is we have this negative sign on the outside. So we can represent this in this way. So we continue to hold on to that negative. We're considering that negative 1 times 64. So another way to think of this is we're basically using the product rule here, right? And again, remember we said that I is equal to the square root of negative 1. So we're going to replace this first part with I. Now we handle the square root of 64. So the square root of 64 we know is 8, so this becomes negative 8i. So in this next question here, we have something that we're going to handle similarly. We're looking for a product of the real number and I. The only real difference is, notice that our radicand is not a perfect square. But we're going to handle this in the same way as we did before. So I have the square root of negative 19. Or that's the same thing as the square root of negative 1 times the square root of 19. Remember, I is equal to the square root of negative 1. So we replace that I with that negative square root of negative 1 with I, square root of 19. And this cannot be simplified any further. So that is our final answer.